Hello, this is Bethany Correa at John Marshall High School, and today we're talking about the area of composite figures. So let's imagine a situation here. We've got Janie and Miguel are painting a mural in the school gymnasium. They will need to paint the entire wall blue except for the circular school logo. How can Janie and Miguel determine how many square feet they will cover in blue paint? Well, let's kind of draw a picture of what this looks like. So we have our wall here, and we have the school logo in the middle. And they're going to paint all of this, okay? So we've got two different shapes here. We have a rectangle and we have a circle. So in order to find the area that they're going to paint, you're going to find the area of both shapes, but then you're going to subtract them because you're taking away the amount of paint that would be covering the logo, okay? It's just like a donut. If you make the donut, you need the donut hole. You take away the donut hole, okay? So that's subtraction. So we're going to be talking a lot about composite figures. A composite figure is made up of two or more shapes. That's our first blank here, composite. Made up of two or more shapes, just like our gym wall. We have two shapes involved. We can find the area of a composite figure by decomposing the figure into familiar shapes. Okay, the word decomposing just means separating or breaking up. So separating our gym wall into a rectangle and a circle. Then you're going to add or subtract the area of each shape. So in our gym wall example, we had to subtract, take away the area of the logo from the wall, but sometimes we're going to add them together. Let's look at an example of that. All right, in this shape here, it says decompose the figures below, then use the graphic organizer to find the area of each shape. All right, first step is to separate the shape into more than one. So when we look at this, we can see two shapes. We can see a rectangle and a triangle. Go ahead and draw a line in between that rectangle and triangle to separate it out. Okay, so we know our two shapes that we're dealing with are a rectangle and a triangle. So in our graphic organizer, we've got the name rectangle and triangle. Let's focus on the rectangle first. Our second row in our graphic organizer asks for the formula, and we know the formula of a rectangle is base times height. Next, we're going to plug in the values for the base and the height. So looking at our rectangle, our base is 9 feet, and our height is 8 feet. So we're going to rewrite our formula as 9 times 8. And then we're going to do the multiplication. 9 times 8 is 72. So the area of our rectangle is 72 feet squared. Don't forget your label. All right, let's look at shape 2. Shape 2 is a triangle, and they did not outright give us the dimensions of the triangle. Notice that these lines are blank, but they did give us enough information here for us to figure it out. So looking at the base of the triangle, notice that's just as long as the base of the rectangle. So it's going to be the same value of 9 feet. And the height of our triangle, when you combine the height of the triangle with the height of the rectangle, you get this huge combined distance of 12. So in order to find the height of just the triangle, let's subtract 12 minus 8 to get the height of the triangle. So the height of the triangle is 4 feet. All right, now let's go back to our graphic organizer. We're trying to find the area of the triangle, and our formula for the area of a triangle is 1/2 BH, so base times height divided by 2. Next, we're going to plug in our values. So we know that our base is 9 and our height is 4. So to solve this, we're going to do 9 times 4, and then we're going to divide by 2. And that is going to give me 18 feet squared. All right, my next step, because we're not quite done yet, I found the area of both shapes. But to find the total area of this figure, we're going to add them together. So I'm going to add together shape 1 plus shape 2. So I'm going to do 72 plus 18. And that's going to give me my final answer of 90 feet squared. All right, I'm going to let you do the next example on your own. Let's discuss part A down here first, though. Discuss the different ways you could determine the area of the figures below. So on the next page, you're going to have some figures that are slightly more complicated. They're going to be more than 2 figures, or maybe you have to add or subtract. So let's discuss how you might solve them by looking at these here. So this first figure, more than one way to divide this up, but I see 3 different rectangles. And I'm going to cut those rectangles here and here. And so then you would just have to find the base and height of each of those 3 pieces and add them together. So for this one, you're going to add all 3 rectangles. Okay. Now in the next shape, I see 2 shapes. I see a rectangle and I see a trapezoid. Now notice that the space in the rectangle surrounding the trapezoid is shaded. That means that you're trying to find the area of the shaded part, and just like our school logo example, you're going to subtract. So you're going to find the rectangle and then you're going to minus the area of the trapezoid. In our next example, I see a trapezoid and a rectangle. If I divide it halfway down there, and since both of them are like that open color, that means that we don't have to do any subtraction. They're combined shapes, so we're going to add them. So we're going to do our trapezoid plus our rectangle. All right, and finally, in this last shape here, I see a square in the middle. So we've got our square. But then I see 4 semicircles, and we're going to add those in. So plus 4 semicircles. Okay, so it's not always just 2 shapes. Sometimes you have to take shapes and divide them into 2. Kind of use your critical thinking skills here. Go ahead and finish this example and then tackle the questions on the back.